Hello everyone. In this video I'm going to speak about covalent structures. Let's get started. There are different steps or rules to draw the covalent structures or Lewis structures. For me I have 3 rules or 3 steps and 3 notes. I'm not going to read them, but I'm going to use them immediately. Let's check what we have here. We have CH4. How I can draw it? We have to follow 3 very important steps. First of all, I have to check how many valence electrons. How I can do that? I need to check the periodic table to know how many electrons each atom has. So we have here carbon and hydrogen. How many electrons carbon has? It has 6, so it is 2, 4. For hydrogen, only 1. So how many valence electrons? How many valence electrons? Don't write VE. Doesn't make any sense. I'm just writing it to help me identify how many valence electrons and how many needed electrons to complete the last shell electrons. So I'm going just to write NE. It doesn't make any sense at all, but for just for me to know that I need 4 electrons. Why I have to do that? Because the needed electrons will indicate how many bonds should be formed or should this atom make. Okay, carbon has 4 valence electrons and it would need 4 electrons. For that reason, it would make 4 bonds. For hydrogen, it has only 1. So 1 valence electron, and it would need 1 electron to complete the last shell electrons with 2. When I'm saying needed electrons, the needed electrons to complete the last shell electrons. For hydrogen is 1, for carbon it's 8. Okay, so hydrogen will make only 1 bond. Which atom will be the central atom? The atom that would make the most number of bonds. So in this case, carbon will be the central atom. Carbon will be the central atom, and carbon will make 4 bonds. As you can see here, the bonds are represented by line. Then we have here hydrogen. That's how I can draw Lewis structure for methane or for CH4. Okay, what about H2O? Same steps. I need to check the periodic table to know how many electrons each atom has. So I have here oxygen. It has 8 electrons, so it's 2, 6. I have hydrogen, 1, 1. How many valence electrons? It has 6 valence electrons. How many electrons needed to complete the last shell electrons? With 8, so 2 electrons, so it would make 2 bonds. How many valence electrons? 1. How many needed electrons to complete the last shell? 1. So how many bonds? Only 1 bond. Okay, so here is oxygen. Okay, oxygen has valence electrons 6, and it would need it needs 2 electrons, so it would form 2 bonds. So it means that we have only used 2 electrons from the 6 electrons. So for that reason, we have what's called lone pairs. What are the lone pairs? The electrons that are not contributing to the bonds. So I have 1, 2, 3, 4. 4 electrons that are not used in the bonds, while I have 2 electrons that will be used in the bonding. Okay, so we have 2 lone pairs, and we have here bond with hydrogen, another bond with another hydrogen, and we have here 2 lone pairs. Okay, so the electrons in the last shell that are not contributing to the bonding, they are called lone pairs. Okay, what about sulfur? Here in sulfur trioxide, we have oxygen and sulfur. Sulfur has 16, so 2, 8, 6. Oxygen 8, 2, 6. How many valence electrons? 6 for both of them. How many needed electrons? Okay, 2 and 2. For sulfur here, we have a very important note. Sulfur is in period 3. Which means that it has an empty d orbital. It has an empty d orbital or d subshell. For that reason, it can extend its last shell with, or it can accept up to 18 electrons, which means that I don't have to consider 8 electrons. No, it can accept more than 8, up to 18. But which one will be the central atom? We have here sulfur. Is it going to use all of its bonds? Let's check. Oxygen would need to, oxygen has to make two, each oxygen atom has to make 2 bonds, and we have 3 of them. We have 3 of them. So we have 1, 2, oxygen, 1, 2, oxygen, 1, 2 with oxygen. Now I have used all the sulfur valence electrons. I have used all the sulfur valence electrons. What about oxygen? Oxygen already satisfied now, but I don't have to forget the lone pairs for oxygen, lone pairs for oxygen, lone pairs for oxygen. One of you will tell me, but now sulfur has more than 8. Yes, it can accept more than 8 electrons. As you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but this is fine.